So, hello and welcome to this AMS podcast with Nitrex. I'm Nick Holt, editor at AMS. Today, we're going to look at one of the important processes involved in component manufacturing. So, where there are specific requirements around performance and durability, certain vehicle components require additional processes and specialist treatments. So, in this podcast, we'll look in more detail at this part of the production process, and to provide some expert insights, I'm pleased to welcome Jason Orosz, who's President of Global Heat Treating Services at Nitrex, a leading company in the surface treatment industry. The company has over 35 years of experience in this field and provides both turnkey heat treatment systems and surface treatment services. So, Jason, just to put some context around heat treatment and surface treatments around automotive components, could you just discuss maybe the kind of current scope and applications for nitriding and heat treatments for automotive components? Could you give me some current context for that?
Yeah, definitely. And first, let me say thank you. It's a pleasure to be here today with you and to get the opportunity to talk about something that's near and dear to me and to us at Nitrex. So to start off, to answer your question, it's a really broad category. So heat treatment in the automotive component industry, it's a multi-billion-dollar industry. And there are many components requiring a lot of different types of heat treatment processes, all at various points in the manufacturing process. So some types of treatments like annealing, normalizing, general hardening, they're typically employed earlier in the process to raw forgings or castings or bar, to allow for easy machining or to provide, the kind of basic strength profile and ductility profile that component manufacturers are looking for. Some other treatments are carried out kind of during or after the manufacturing process is completed. And some examples of these are stress relieving to ensure good dimensional stability of the components. Let's say, for example, if you have significant stock removal, or surface treatments such as gas or low pressure carburizing, or nitriding and ferritic nitric carburizing. And these are generally applied to components that are substantially finished or completely finished. And these provide a relatively thin, hardened zone near the surface of the part, which helps with wear resistance, corrosion resistance, fatigue resistance, and those sorts of things.
A big topic for us at the moment is the transition to electric vehicles and the associated changes in componentry on the vehicles around powertrain and etc. Has the demand for the processes you described there increased with this transition to electric vehicles at all?
The transition to electric vehicles, it's a very dynamic situation, and manufacturers as well, it's quite a dynamic situation for them as they continue to revise their component designs, and then the corresponding manufacturing processes that are required, in order to carry out those designs. But in general, the picture that seems to be developing is one where the total number of components requiring heat treatment, it looks like it's expected to decrease, mainly because in general, electric vehicle powertrains are much simpler than equivalent internal combustion engine powertrains. There's just a lot less moving parts. So because of that, there are a lot fewer components that will require treatment for resistance to fatigue or wear, or requiring increased strength. However, what we are seeing is that because the overall mass of an electric vehicle seems to be a bit heavier, than an equivalent internal combustion engine vehicle, there's likely a need that's developing where we see certain components in suspension, in braking and steering systems where they'll need additional heat treatment or potentially additional mass, which results in obviously a higher heat treated mass for those in our industry. That should help offset some of that decline for heat treatment and surface treatment, excuse me. I'd say probably one other area that we're seeing is that as the capability of certain surface treatments, especially like nitriding and ferritic nitrocarburizing improves with respect to the ability of these treatments to prevent corrosion, they're starting to be adopted, more often, and for applications which previously were served by less sustainable painting or plating processes, especially.
Could you describe a couple of those areas, Jason, in a bit more detail where you're seeing that additional uptake of those processes?
Yeah, certainly. We see certain examples where it's purely a substitution on the basis of corrosion resistance. And these would be basically anything under hood or under body that maybe potentially was e-coated or had like a zinc flake spray. And then where these treatments really shine are those applications where there's a combination of wear and corrosion resistance required. Because surface treatments like nitriding and nitrocarburizing, it's not a coating. It's a metallurgical evolution of the steel itself. So there's nothing that can spall off or have a catastrophic failure. And so applications like brake pistons that were previously chrome plated. Chrome plating it's a fairly nasty process environmentally. There's some hexavalent chromium wastes that are carcinogenic. And this is a good example where many OEMs and tier ones are moving to a nitrocarburized brake piston versus what's traditionally been chrome plating, either due to their own environmental goals or even because there are less players in the chrome plating market than there used to be, because it can be more challenging to find a supplier. Another good example is something like a door latch. It sits in your door. It's exposed to the elements periodically, and it gets every time you open that vehicle, there's a bit of a wear action that happens. And in this case, something that can provide a combination of wear resistance and corrosion resistance is a really good choice.
That's really interesting to see that the coatings you're speaking about are replacing some of the traditional, like you say, the e-coatings under the bonnet and components around that. Are there any components that you're focusing on at present, and what are the kind of particular requirements that you're addressing? I mean, I've made a note here about brake rotors, in that it's supporting upcoming Euro 7 legislation. I mean, can you shed a bit of light on that?
Yeah, that's a great one to start off with. And as you mentioned, brake rotors are a very significant source of particle emissions. The Euro 7 is seeking to reduce particle emissions from many different sources. Brake rotors are one of those sources. What we're seeing is that in general, especially with the transition to electric vehicles, ferritic nitrocarburizing of brake rotors is gaining in popularity. With internal combustion vehicles, they also have brake rotors, but the treatment was really only supplied on premium vehicles because of the added cost. But with the adoption of regenerative braking systems, you'll see that the pads aren't used as often. And the result is that the contact surface of the rotor is more prone to corrosion and buildup of corrosion over time because it's not being continuously cleaned off by the pad system. So what we're seeing is that many OEMs are starting to adopt ferritic nitrocarburizing, and in some cases, ferritic nitrocarburizing plus a post-oxidation kind of blackening process for corrosion resistance in their designs. Typically, what you'll see is that the treatment specified is a protective compound and oxide layer in the range of 10 to 25 microns thick, depending on the requirements. And what happens is that you don't see that red rust, almost immediately on the rotor, even as it's sitting on the dealer lot. And over time, that carries through and results in less particles being released to the environment, which is what the focus of the Euro 7 is.
You said there's greater demand around components that you haven't usually dealt with. Was one of the reasons for that you've improved or enhanced your treatment processes at Nitrex? Are they in continuous development in the sense that they become more efficient, more sustainable?
That's right. I mean, as with most manufacturers, we're continuing to push the limit of what's possible. Improved process controls, the development of new sensors and control systems has allowed us, to really push the envelope with regard to the types of layers that we can produce. And as we can improve the qualities of the surface layer, what you've seen over the last few decades is that we've been able to improve the performance of those layers with respect to standardized salt fog testing like ASTM B117, or some of the cyclic corrosion testing operations that are favored by a lot of automotive OEMs. So, we've really been able to improve probably, by a 150% factor, over the last 10 years, what the treatments are capable of. And that's resulted in exactly what you're saying.
Have digital tools played a part in that, in the improvement of the process efficiency? I mean, are you able to simulate processes in advance as you're changing perhaps chemistries or something like that? Is that something that you utilize?
We do. We have an R&D operation, within our company. We have several sites, in North America and Europe that their main focus is carrying out iterative experimentation to continue to document, what works and what doesn't. And then, we're able to push this improvement in process design and process control design out to our customer base. In Nitrex, we're actually really uniquely positioned as one of the only manufacturers of heat treating equipment and controls that also has a commercial heat treatment services division. We have 9 plants on 3 continents, and where other equipment manufacturers might be able to develop something at a lab scale, we're fairly uniquely positioned to be able to take it from the lab scale and actually commercialize it and be able to tell our customer base with confidence, yes, this works at full manufacturing scale.
And that's a great advantage to have, because we know from talking around various other parts of the automotive industry and manufacturing that ramp up is quite challenging at times, especially if it's something
Right.
new or it needs that validation. But the ability to, as you say, industrialize it is quite a challenge in some aspects. So that's very interesting to hear. Going a bit more back to your work with your customers, you mentioned there have been some changes around what they're asking you what you're employing your services and treatments for. But are you seeing a broader requirement for higher quality and performance standards across components now?
Oh, definitely. I think it's probably no surprise to anyone. It's been a continuous progression, to higher quality and performance over the last few decades, since I've been in the industry. Manufacturers are always looking to improve quality and save cost. And often this involves employing tighter dimensional tolerances and more demanding metallurgical requirements. So naturally, manufacturers have looked to those of us in the industry to rise to that challenge and improve, the capability of our processes. This kind of push has led to the adoption of better process controls. And like I mentioned, Nitrex has been the leader in this respect for nitriding and ferritic nitrocarburizing over the past 35 years. And I would say now that modern process controls that are required, I would say, for most automotive component manufacturing heat treating, now that most furnaces have those types of modern controls, the focus is really on using those to improve repeatability, environmental footprint, cleanliness, traceability, and those things that provide value. So improving these characteristics, it really allows us and our customers to operate in an increasingly lean way. And that's one of the ways that cutting edge heat treatment equipment and service suppliers like us, provide value to component manufacturers.
You touched a bit on it around the brake pistons themselves, around the replacement of chrome plating.
Mhm.
But how does sustainability factor into the processes you specialize in? And certainly in the context, if you look at your automotive customers now, because a major part of the design or production of any product is having sustainability, a lower carbon footprint built into that design. And we're talking to a lot of suppliers across the board and that's a key factor for them when they're presenting, whether it be a service, a treatment, a component to the OEMs, car makers. How does that factor in for Nitrex?
Definitely. I mean, and you said it, OEMs, they've begun to push, sustainability goals down through their supply chain. So even as a component manufacturer or as a heat treater, if you don't have your own sustainability goals, you're going to begin to see those, if you haven't already, coming directly down from the OEMs. So to date, we haven't seen many concrete targets being set, but the requirement to monitor the environmental footprint and a general commitment to improve, that's kind of what we're seeing right now. And that's the obvious first step. I would say, it's likely that targets are going to follow at some point, once an industry baseline is established, for the types of treatments that, are common, in the automotive heat treatment supply chain. And for us, for Nitrex, due to the relatively low temperature of treatment, nitriding and ferritic nitrocarburizing, which is what we specialize in, these are generally less carbon intensive because, you don't have to expend the same, number of kilowatts to heat something to 550 Celsius as you do to heat treat something at 950 Celsius. It's just kind of natural. And I think that, this type of, I guess, sustainability advantage is probably going to lead to increased adoption of these processes, maybe at the expense of some higher temperature treatments, where you can achieve a similar metallurgical and functional outcome. In general, heat treating in general, I would say, has benefited from lightweighting initiatives as well, as OEMs and component manufacturers have, designed components to be lighter and stronger. Naturally, you can see where heat treatment is often essential, in increasing the strength to weight ratio of a particular component.
You're right, and it's very interesting when we talk to tier suppliers and suppliers across the board, is that the absence of standards is quite tricky for companies
Right.
like yourselves to prepare for, and different OEMs ask for different data sets, etc. So
On the subject of data, really the next evolution in our space is going to be improved use of data in machine learning and cloud computing to further drive sustainability and repeatability. And using these tools to analyze and monitor process control is really going to drive the next wave of improvements in efficiency. And that's naturally going to lend itself to improved carbon footprint in heat treatment and surface treatment. And one of the initiatives that we've made significant investments in is this machine learning cloud computing space. And we've actually developed a tool called Cumulus. And it's basically a state-of-the-art piece of software that you can connect all of your heat treatment furnaces to, and supporting equipment as well, like washers and blasting equipment, basically anything that you'd find in a heat treatment department or a heat treatment plant. And it basically, it's compliant with all the regulatory frameworks that are out there, both in Europe and North America. It's hosted in, AWS, Azure, as you please. And what this is going to do is it's going to allow artificial intelligence models to notify you as your process is potentially deviating from a certain state that leads to a predetermined successful outcome. So analyzing thousands and thousands of previous heat treatment processes for a component allows us to develop a model that predicts, an outcome of good quality versus an outcome of potential poor quality. And this is something that's really exciting for us.
are you seeing a lot of different materials being presented to you? But are you looking at seeing different sort of grades of steel and alloys that are being presented for your treatment services? Are they changing?
Yes, we are seeing some new alloys with maybe slightly different, microalloying content. that is definitely happening, especially in, I guess, body components, panels, frames. And we're also seeing the same old grades that we've always seen for the last 50 years as well. Generally, it's going to be very difficult to transition away from an 8620 carburizing steel, for a lot of applications. So there's a lot of innovation, and then there's a lot of continuing deployment of what works.
I just going onto the hardware side of things at the moment. I'm just interested to know kind of how the automotive industry is interacting with you to some extent. A couple of questions on this, really. We've seen over the years, and maybe slight acceleration of it now, is that where car makers were divesting themselves of a lot of their external processes, or the processes that they had in-house, there has been some degree of reintegration of that, some becoming more vertical again. Nitrex, you offer both turnkey treatment systems that the OEMs can buy, or the tier suppliers can buy, and also you mentioned there the process services that you have on your various plants, various facilities. Are automotive customers increasingly looking to acquire the equipment from you to bring the processes in-house, so they have that competence in-house, or are they still relying on you quite heavily for process by yourselves in your own facilities?
It's a great question. So I think, what I've seen in my career, like you said, having, a bit of a foot in both camps, is that during times of change, what we see is that OEMs and manufacturers really enjoy having that control over their processes as something new is deployed. And then what we've seen is that as those types of processes are, I guess, become more common, more routine, and not necessarily processes, but employing a particular process for a particular reason on a certain type of component. As this becomes more routine, then there's a tendency to shift more to an outsourcing model where manufacturers and OEMs can focus on their core competencies, which are typically component design. Maybe they have a specific way of manufacturing a type of component that's, a real piece of expertise that sets them apart. So, when floor space is limited, they will always tend to focus on their own core competencies and outsource whatever is available and it makes them comfortable to outsource. So we've seen a bit of both. As you said, right now, it looks like we're in a bit of a period of change, and we've seen a lot of requests for equipment, especially, in the brake rotor space. This is something that, we're seeing a lot of activity for from OEMs and tier one component manufacturers. Additionally, heat treatment equipment is very capital intensive, to deploy. So typically we see that manufacturers are very willing to allow third parties to make that type of investment, where they're comfortable doing so, due to the application being well established in the marketplace.
You're right, and it's very interesting. We see with car makers that because they're working in as you say, a period of great change, and they are having to bring in a lot of competencies that they didn't have in the first place, and would bring in the expertise. And I think almost that's driven a slight mindset in the sense of looking more broadly at their operations, what they can bring in-house, and as you say, perhaps a sense of and actual retention of control with that. So it is interesting to see, as you say, the ebb and flow of that a little bit.
Yeah. Control over your own destiny, right?
Yeah. And I think at the minute, a lot of the automotive industry field doesn't feel like it has much control over its destiny.
Yeah. Well, it's kind of the same concept you mentioned earlier, kind of absence of standards. Well, I think here we have an absence of a path forward in terms of component design and even what the market is going to want. We're talking electric vehicles. There's still a conversation about hydrogen. There's a lot of different ways that this could all play out over the next 10, 15 years. So having some minimum in-house capability I think it's a logical and a good step for a lot of manufacturers.
Yeah, and it's interesting because the automotive industry historically has been, the foundation of it has been standardization and repeatability. So
Hmm.
all of this uncertainty is definitely unsettling. And as you say, we've spoken to a lot of suppliers, and there is a big question mark going forward. No one supplier can say it's definitely this trend or definitely this material, or
Hmm.
very much in flux all the way through the whole value chain. So yeah, interesting times that we're living in. Certainly for a journalist, it's great to write about all of this. Just going on to one last question, Jason. I just sort of building on that. I mean, one of the things we're discovering is the working relationship with clients is, we're seeing, especially sort of the large car makers and the tier ones, tier twos, maybe, in the sense that rather than being an equipment or a simple service or component provider, suppliers now are entering into much more of a technical partnership. So they're involved further upstream. They're more involved to some extent in the design and production process that the OEM is working across. So they have some say, some influence, some input. Are you finding a similar thing now with your clients?
Definitely, and I would say that we've always tried to foster those types of technical relationships, because at Nitrex, we believe that that's what sets you apart. Supplying a widget, is a much less. Uh, there's a lot less of an intimate relationship than being involved in collaborative, iterative design, of a component, and so we've always tried to be that resource for our customers. We're present on, like I said, 3 continents, many different countries. So wherever that component design and R&D is happening, we're typically able to help our customers and allow them to leverage our metallurgical knowledge and our knowledge and experience of typically what works both from a metallurgical standpoint and also from a production scalability standpoint for heat treatment. So that's definitely something we're seeing an increased desire from our customer base. And I think part of what is driving that could be the fact that there, I would say, is a deterioration, as in many industries, in our industry, of knowledgeable, experienced, professionals with that metallurgical depth. So I think that's going to be a trend, not only in our industry, but in many industries where customers really look to collaborate with their suppliers, as a way to compensate for difficulty in finding, those skills to add to their own teams.
That's a very interesting point you're making there, Jason, actually, because again, skills gaps are a major problem to anyone we
Yeah,
speak to at the moment.
that's
So,
right.
and again, as you say, that is leading them to look to companies with their own experience and to draw upon that and lean upon that.
And I think the other thing that it's going to do is further drive people towards AI and ML, where you can, harness data to use in some cases in place of, knowledge and experience. So having those tools available where, you can crawl, the last 5,000 recipes or processes that you've carried out, and draw some conclusions, to kind of guide future development, rather than have to, rely on an individual or group of individuals to do that for you. I think that's going to be part of the next wave of evolution in our industry as well.
And that's a great point to finish on there, Jason. Bringing AI into the conversation, it's a definitely one to watch. So, with that, I'm going to say, Jason, thanks very much for your time and insights today. It's been a pleasure speaking with you. Some really interesting points you've made there, and some good insights into the processes and requirements and into Nitrex. So, thank you very much for that.
Oh, anytime. It's been an absolute pleasure. Thanks very much.
This was an AMS podcast with Nitrex. Thanks for listening.